Right, to briefly end lecture 4, I would like to give you also a very briefly overview of one paper that considers like inference after model selection to asset pricing. Okay, so it's this paper by Feng, Giglio, and Chu, terming the factor zoo test of new factors, published last year in Journal of Finance. Okay, and the idea is the following. Hundreds of risk factors or anomalies have been proposed in the last 30 years, right? So we have this, what we call the factor zoo, okay, like more than 300 different factors. And the authors of the paper, they basically say that most of these factors are redundant, and also their significance in terms of asset pricing models is due to omitted variable bias, like the number of controls in the models are insufficient. Okay? So for instance, a redundant factor may only be useful relative to the Fama-French 3 or 5 factor model, but not relevant when you include a larger set of factors, right? So the question is, suppose that some economic theory, model, intuition, stories suggest a new factor. Is it truly new and is useful in pricing the transaction of assets, or it is more of the same? Okay. So there are kind of 100 factors introduced in the last 30 years. There's this paper by Green and co-authors, right? And 14 factors on top finance journals in the last 5 years, so just the last 5 years, I think. And the question is, how many of them are really new? Okay? And what's the right benchmark? Is the 3 from a French factor, market size value? There are other benchmarks. Okay? How about controlling for all factors proposed by the literature? Okay? So standard analysis like Fama Macbeth will be infeasible due to the curse of dimensionality, of too many factors, right? So we need something to put some discipline on that, on the zoo, and the idea of this paper is to use machine learning, basically Lasso, okay? And the problem is that Lasso makes mistakes. We have just seen, right? Lasso making mistakes. So you have to correct for that. How we are going to correct for that? We are going to use like the double selection method, right? So Lasso may miss true factors, so it will introduce omitted variable bias again. So when we use double selection, as we have just seen, we are going to overcome this problem. Okay? So let's first see what Lasso does. Let's pick a factor G and see if Lasso selects it. G, a general factor. Okay. So what we have here is a data set of 1825 different assets, so 1,825 assets. We have 99 factors, and we have data from 1980 to 2016, monthly data. Okay. And what we are going to do, we are going to do a random bootstrap, randomly sample from these 1,825 assets. And then we are going to regress average returns on factor covariances. And we check if Lasso will select these factors. Okay? What we see here is that we have results all over the places. We have like even prominent factors like market, it's not selected 100% of the time. There are some samples where it's not even selected. And size and value factors are not selecting that frequently. And on the other hand, you have something like sales to inventory that's selected even more than the factor. So maybe there's something wrong here, right? Depending on the sample, you can have completely different set of factors, right? And so Lasso is very unstable. Lasso cannot always select the true model, okay? And this is because we are making mistakes. So what we are going to do, how we are going to use Lasso to select the controls, like the benchmark when we are testing for an additional factor. Okay, so the idea is that similar to what we had before. So the thing is that we have returns. We want to test if a given factor G is significant, but we want to have like a set of covariates here, and we want to, plus an error, and we want to select this set of controls here when we are testing if this additional factor is relevant or not. Okay? How we are going to do this, if we are doing single selection, as we did in the previous slide, we are going to miss some relevant factors, and we are going to include some irrelevant factors. Okay? And that's because Lasso makes mistakes. So what we are going to do, what the authors propose, is to use the double selection that we saw during the second part of this lecture 4. Okay? So what's the idea? We do a Lasso regression on average returns on factor covariances, and we regress the covariance of interest, the additional factor covariance, on the remaining factor covariance. Okay? And we are going to select the controls that appears to be relevant in any of the two regressions. So the final step is to regress average returns on the covariance of the additional returns, and then in the selected factor covariances. Okay? And we are going to I'm going to show you a simulation exercise, like trying to mimic the real life with 100 factors. Okay? And basically what you see, the panel on the right is like comparing the true selection rate with the with double selection, so for useful and redundant variables, and the dashed lines are the true distributions, the gray histograms are the empirical ones, so you see that we are right on top. When we use just single selection, you see that the two distributions are not exactly centered, so that means that Lasso is making mistakes. Okay? So bringing this technique to data, so again 99 monthly factors and anomalies like momentum, size, value, growth, investment, profitability, intangibles, and trading frictions. Okay? And they also included like 197 non-tradable factors. Okay? So they have 1,825 portfolios as test assets. So they're not looking to specific assets, but they're like looking the relevance of factors on these test portfolios. Okay? And portfolios are sorted by all characteristics. Okay? So the question is, a new factor helps. So basically, let me go directly to the results. So I'm not going. There are more details in the paper and on the slides, but what I want to say to you is that among all these zoo, there are kind of like 4 factors that turn out to be really significant. And they are basically investment and profitability. Okay? And this shows to be very robust. And this table is also interesting because they are going to do this recursively. So every year for 1994, there were like 450 test assets. There has been like 22 controls already proposed in the literature, 22 factors. There are 2 new factors being proposed in the literature. Okay, here you just have the numbers. So 23 and 24. 24 is irrelevant, 23 is relevant. Then 1 year later, there are 50 more assets, 2 more controls, the previous two, and 3 new ones. None of the 3 are relevant. 1996, again 527 because it's 24 plus the other 3. 2 new, non-relevant. 97, 29, 1 proposed, 1 relevant. So overall, if you do this in a sequential way, you only see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 relevant factors if you do this in sequence. Here, the difference from here that you are not doing in sequence, you're taking everything together. So it's not compared to what we had previously. Okay? And here's like a sequential way. So what you can see is that not many of these factors are really relevant. So what, in the end of the day, what we have is a very, very small number of factors. Okay? So that's an application, a briefly review on how to use double selection and in asset pricing and why inference is important. Not only prediction, not only forecasting, but inference is also important. So thank you. See you on Friday. See you during office hours on Thursday. And we can discuss much more about these during our live session on Friday. Okay, thank you.